In this video, we're going to talk about another probability distribution called the normal distribution. But before we go to the normal distribution, let us talk about the discrete random variable versus the continuous random variable. So, the discrete versus continuous variables has been discussed in the first part of this lesson of this subject or course. That when we say the variable is discrete, this is something achieved from counting, and the distinct feature is that we don't have values such as zero point 0.5 or 1/4 or 75%, or not 75%, but 75.70. Let's make it 70.5% or anything of that sort. We don't have a point something, we don't have a half, we don't have a part of a whole. It should be really just one whole object, such as number of patients, such as number of cars, and all those things. So that is what we consider a discrete random variable. Whereas when we talk about a continuous random variable, this is obtained most of the time by measuring, which would imply then that its distinct feature would that we would have a zero point 0.5, 0.2, a 1/7, a 0.5%, and all of those things. So these parts of a whole are counted if the variable is continuous. And it is the same definition when we talk about random variables. Now, the last distribution that we talked about is a binomial distribution. And the binomial distribution is actually a discrete random variable distribution, because as you might have noticed, the values of our variable x would be number of people or number of objects that would either have a success or a failure for that specific event when we talked about the binomial distribution. But this time, the normal distribution would be more of a continuous random variable distribution, wherein we would have to encounter probabilities of having a half, a fourth, and so on. The normal distribution curve. A normal distribution curve is a symmetrical bell-shaped curve defined by the mean and standard deviation of a dataset. The normal curve is a probability distribution with a total area under the curve of 1. Now, as you might have noticed, the normal curve is a probability distribution that is described as a curve, as the name implies. It is beyond the scope of our course, but we can actually show that the binomial distribution or any probability mass function can be described as a histogram. And as you all know, a histogram is a bar graph that has no spaces rather. However, now these bar graphs, or these histograms rather, would now become very close because we now consider the 0.5, the 0.2, the 0.3, and so on. So that those distributions from histogram, such as the normal distribution, now we have what we call now a curve, which we would see later on what it will look like. Why are normal distributions so important? Many dependent variables are commonly assumed to be normally distributed in the population. If a variable is approximately normally distributed, we can make inferences about values of that variable. Example is the sampling distribution of the mean. So what? The normal distribution and its properties are well known, and if our variable of interest is normally distributed, we can apply what we know about the normal distribution to our situation and find the probabilities associated with particular outcomes. Most, if not all, of the variables would usually be normally distributed or assumed to be normally distributed. And these variables that can be assumed to be normally distributed or are normally distributed have specific properties or have specific characteristics that would make it easier for us to tell some things about the population, and this serves as a basis later on for our inferential statistics. Some properties of the normal curve. It is a theoretical construction. It is also called bell curve or the Gaussian curve. It is a perfectly symmetrical normal distribution. The mean of a distribution is the midpoint of the curve. The tails of the curve are infinite. Mean of the curve equals median equals mode, and area under the curve is measured in standard deviations from the mean. These are just some of the properties of the normal curve or the normal distribution, but let me highlight two of the most important and two of the most powerful properties. We have the mean of the distribution is the midpoint of the curve, which is quite similar to this one. Saying that the mean of the distribution is the midpoint of the curve is similar to saying the mean is equal to the median. Further, later on, as you can see, the mean is equal to the median and is equal to the mode. So we don't have to be bothered on which measure of central tendency to use, because whichever we choose, we will just have one same value. And that becomes very, very powerful because we our measure of central tendency is very strong. It it represents rather all the values because it's an average of all the values because that's the mean. And even though it's the mean, it's an average of all the values, it is very resilient to outliers because it is the median. And at the same time, it is the most occurring score, it is the most frequent, it is the most common score because it is the mode. And that value will become very powerful when we do our inferences and finding our probabilities. So, to know more about the normal distribution, let us go now to the next video.